So in this video, we're going to check if the solution for this equation, if it exists, and if it's unique. And to do that, so we have our equation right here, dy over dx, so this is a derivative, it's equal to 2x squared y squared. And we're given this point. We have to check at this point if a solution exists. So we see that y of 1, so our x is 1 and our y is -1. So our a and b would be 1 to -1. And we rewrite the solution here as f of x because we're just trying to check if the x, at the x interval, if we put 1, if we check at the point 1, are we going to find a solution here? And you can already see that this is probably continuous everywhere. It is continuous everywhere because there's nothing you could put in this to make it not continuous, right? There's no like denominators, no nothing. So if you were to plug this in, you would see that this is continuous everywhere. This equation is continuous everywhere, right? 1 plug into x, you put -1 into y, it works. There's nothing, there's no error. So this is continuous everywhere. Now, to find out if it's unique, you have to take the partial derivative. And the way you do that is you have to take the partial derivative with respect to y. And the way to do that is to treat x, the entire x variable, as a constant as well. So this is not a variable anymore. You're taking the partial derivative. In that respect, this entire thing is a constant. It would be no different than having, for example, if you were to write here 5y squared. This is the same thing. This entire thing would be the same as y. I'm not saying the value of it is equal to 5, but just the way 5 is a constant, this entire thing is a constant now. And how would you derive this? You would just multiply 2 to the beginning, right? 2 times 5 minus 1. So what would that give you? 10 to the y, right? You do the same thing here. You multiply 2 times 2. You bring the 2 to the front. This is derived with respect to y. You bring the 2 to the front and you get 4x squared y. Now this is a partial derivative and you get this. And now we see that this is also continuous everywhere. So this first part was to determine if this equation or if this solution exists. It does exist. The solution exists in the neighborhood. There's a solution in the neighborhood of this point. At least one solution. There's a solution here. And now we see that that solution is unique. So the first part, you do this to check if there's a solution. The second part, you check to see if it's unique. And we could see that in the neighborhood of this point, 1 comma -1, so x value 1, y -1, there is a solution that exists and that solution is unique. So that this means that we have one unique solution in the neighborhood of that point. So yeah, that's how we do that.